So we're going to spend today and tomorrow talking about scatter plots. So just to kind of give you a little bit of information, and some of this you already have. A scatter plot is a graph that shows the relationship between two sets of data. And when it has those two sets of data graphed, it has them graphed as points on the plane. So you guys know what scatter plots are. Like, that's not brand new information to you. You've seen linear scatter plots before. So linear scatter plots are when you have an x and a y axis. And you can have two types of correlation there. You can have positive correlation, which means that your data is going to be going in an upward trend. It may not be perfectly straight, but it's going in a linear looking graph if you were to describe the direction it's going. A negative correlation is going to have the same concept, except it's going to be going down. You can also have quadratic and exponential correlations, and that's the ones that we're going to be focusing on today, because that's the ones that are going to be fairly new to you, because we for sure haven't talked about them, and you might have been introduced to them in Algebra 1. That is a possibility. So when you have a positive quadratic correlation, that just means that your scatter plots, when they form like a parabola, and that parabola is opening up. Negative correlation is going to be kind of the same idea, except they're going to form a parabola that's opening down. So these are just examples of what those correlations might look like. We could also have exponential correlation. Exponential correlation is going to look like exponential graphs, which we've been looking at for the last couple weeks. And exponential graphs, they have an asymptote, so they're going to kind of start off flat and then they increase. It's almost like having half a parabola. That would be positive exponential correlation. Negative exponential correlation is going to be doing the opposite. It's going to be going down. And again, it's going to start off kind of curvy and then almost look kind of flat there. Whereas positive starts off kind of flat and then goes up. So your biggest thing today is to decide what kind of correlation do you have. So most of what we're going to talk about is linear correlation, but that's not all we're going to talk about. So I'm going to spend the rest of this time, like on our notes, talking about the linear stuff, kind of show you some things on the calculator, and then I'm going to do a problem off the homework with you, or just to kind of get you an idea of what it is that you're really going to be doing. So when you're talking about linear scatter plots, this is really important. With linear scatter plots, you can have what's called a trend line, or a line of best fit, that you can use to kind of model your data. So for example, in this graph that I drew of positive correlation, a trend line would go through the middle that kind of models the direction that the data is going. I could do the same thing with the negative correlation. And we're going to be spending a lot of time, like I said, focusing on those lines. You can also have curves of best fit for nonlinear data. I'm going to show you how to get the equations of those in a minute, but that's not going to be the most important thing. The most important thing we're going to talk about today is the trend lines and what we use them for with linear data. We're going to spend a lot of time focusing on this because it's something that's going to show up in AP Statistics, which a lot of you guys are taking next year. There's a couple things that you're going to need to know in the calculator, so I've given you some steps here. And that's, first of all, is how do you find the equation for the data in the calculator, which that's what one of our main focuses today is how do we find an equation to model this data that we have based on whatever our graph is. So first of all, we have to decide what kind of data is it. Is it linear, quadratic, or exponential? If it's linear, you've got to make sure that you turn on what's called stat diagnostics, and we're going to talk about in a second what that's going to do for you. But over here, this shows you what you're looking at, where you're looking for where it says stat diagnostic, and here's the steps. So if you'll go ahead, go to mode right now in your calculators, scroll down to stat diagnostic. It's going to be on the second screen, and you want to make sure that on is highlighted. So you want to make sure that on is highlighted, that it's blacked out. And then to find our equation, the second thing we're going to do is type all of our points in stat edit. Put your x's in L1, y's in L2. And then after all the points are typed in, which you have to have at least 5 of them, you go back to stat, over to calculate, and then pick the correct equation number. So if your data is linear, you're going to use stat calc 4. If your data is quadratic, you'll use stat calc 5. If your data is exponential, you'll use stat calc 10. And then you're pressing a bunch of times so you get to the next screen, and it's going to give you your equation. We're going to do that in a second. I'm going to get the calculator up, but these are the steps here, and you're just going to want to make sure that you flip back and look at these, because these steps are going to be really helpful. And in a second, we're going to talk about why we need this stat diagnostic tool. So the reason you need the stat diagnostic tool is because there are two diagnostic things that we look at when we talk about linear correlation, and those are the two things, R and R squared. So and you'll see this again pop up in a second. When you look at your calculator after you've done linear regression, you're going to see this right here. You're going to see this box where it's going to give you, I know, very specific things here. A is some number, it's your slope. B is some number, it's your y-intercept. R squared and R are the two other things we're going to talk about today. R squared is what's called the coefficient of determination. That's something you're going to learn about in stats. It's basically telling you how accurate your predictions are going to be. But again, that's something you're going to learn about in statistics. I'm just focusing today on showing you how to find it, and then in statistics you'll learn like what it means and how you really interpret that. The other thing we're going to focus on is what is called R, and that's the correlation coefficient. So that's all of this up here. The correlation coefficient tells you how close your points are to being a straight line. That's really what it boils down to. How straight are they? So if your line is perfectly straight, then that means that you either have a negative correlation or a positive correlation. If it's perfectly straight, then your R value is 1 or -1. The -1 part tells you that it's decreasing, that it's going down, and the positive one tells you it's going up. But if R in your calculator is 1, then it's going to be a perfectly straight line. So the closer it is to 1, the straighter it is. So as you see, like here at 0, we're going to get a number for R in a second. And if you get 0, that means there's absolutely no correlation, that it's truly a scatter plot. Like there's no trend in the data. If you're not sure what correlation is, remember the word correlate means they're connected, that there's some relationship there. So if they're all over the place, there's no relationship between the data. So the closer it gets to 0, the less and less correlation that it has. So it kind of falls into like really 3 different categories. You can have strong correlation, moderate correlation, or weak correlation. And then from there you decide whether it's negative or positive. And that literally just depends on the number. So if the number, I'm going to turn this way so we can look at this a little better. So if the number is between 0.7 and 0.1, then it's strong. It doesn't matter if that number is negative or positive, that's still strong correlation. And then if the number is between 0.3 and 0.5, again, it doesn't matter if it's negative or positive, that's moderate correlation. And if the number is between 0 and 0.3, that's going to be weak correlation. The sign only tells us the direction. So the sign here just tells us whether the data is going up in a positive trend or if the data is going down in a negative trend. That's it. So that sign just tells us which direction the data is going. So again, the closer R squared is to 1, the straighter the line, the stronger the correlation, and the closer it is to 0, the weaker the correlation. The last vocabulary words I'm going to teach you are interpolation and extrapolation. So interpolation happens when the data you want is inside the data you're given. Extrapolation happens when the data you want is outside the data that you're given. So, and again, I'm going to do a couple problems that will kind of make all this make sense, but I needed just to introduce all of this to you. So I'm looking at problem 5 on the homework, and I've already graphed these points for you. So if you look at this and you were to say, okay, so think back and look back at the first page of your notes. We need to, based on our instructions, construct a scatter plot. That's done. State if there appears to be a positive, negative, or no correlation. Well, looking at this data, I would say that it's increasing, so this is going to be positive correlation. So I'm going to write that down. This is positive correlation. And then when there's correlation, identify the relationship as linear, quadratic, or exponential. So this would be, if I'm looking at this based on my options, well, if there's no curve here, I would say this is linear correlation. If you look back up at the top, you can kind of see what some exponential correlations look like, because I would say honestly that 3 and 4 are both exponential. Just the way they go, this one starts off kind of flat and it increases quickly. This one decreases and then kind of ends up flat. So these would both have what I would call exponential correlation. And quadratic correlation, remember, that's going to have a parabola with it. So if I want linear correlation, or if I have linear correlation, the next thing I'm going to do, and this is on your instructions on your homework, it says to find the equation for the line or the curve of best fit. So we're going to use the calculator to do that. Okay, so I have put my points in stat edit. So I just took my tables that I currently had in my graph here, and I put everything that was an X, everything on the left side here went in L1. So all of this I put in L1 over here on the left side of my graph, and all of my Y's, everything that was on the right side, I put all of those in L2. So all my Y's went over here in L2. And just so you know, I always look at the bottom and make sure that my points line up, that like I have the same number of points on both sides, otherwise it's going to have an issue. So make sure that like you have the same number of numbers on each side of that. So I'm going to go back to stat. So just so you know what I did here is I went to stat and I went to edit, and that's how I put my points in. Okay, if you don't have L1 and L2, do a reset on your calculator, and that should clear the memory and reset that. So now that I know that my points are in here, I've got them in, I know it's linear, so I'm going to go back to stat. So I'm going to press the stat button again, which is right here below delete. I'm going to go over to calculate at the top, and then this is where I decide which equation I want. Well, if it's linear, I want 4 because it says linreg. Quadratic says it's 5 because that says quadreg. If I scroll down to option 0 is exponential regression. So we want linear regression because our data is a line, and truthfully, it doesn't matter if you see, if you use 4 or 8, they're both going to work here. Okay, so I'm going to go down, oops, sorry, didn't mean to do that. I'm going to go down and pick 4, hit a bunch of buttons, and it takes me to this screen. And this gives me, sorry, my hand got in the way there, trying to figure out where the camera is. This gives me my equation here, which would be y equals, and just round to the nearest thousandth, 0.003 x plus 8.037. So this would be my equation for the line of best fit. So I know this didn't give me r squared, and I'm going to get to in a second like when we need that. I didn't ask for it on this problem, so I didn't worry about that. So for problems 5, 6, and then 7, 8, 9, and 10, this is what you're going to do. But you need to make sure that you choose the correct equation that you need based on this information here, whether you need linear, quadratic, or exponential. Okay, so the last question I'm going to do with you is question 11. So the data below is shows there is a close relationship between the air pressure inside a hurricane and its maximum sustained wind speed. So you've got this graph, you have a table over here, and you're supposed to use the table to find the equation for the line of best fit. But this asks you for a bunch of other stuff. It asks you for the correlation coefficient. It asks you for the coefficient of determination, or r squared. For both of these, we have to have our stat diagnostic turned on, which I mentioned that a second ago, but I'm going to show you how to do that now. And we're actually going to do this whole problem pretty much with the calculator. So to turn on our stat diagnostic, we're going to go to mode, and we go all the way down here to the second screen, and we're looking for stat diagnostic. Currently it's off, and I can see that because the word off is highlighted black. I'm going to move over here and turn it on. And in a second, when I do my problem again, this is going to give me all new information. So I've got my stat diagnostic turned on. I'm going to go to stat and edit. To get rid of my points that are already here, I go up to L1, I hit clear, and then I hit enter, and that gets rid of that whole list. Do the same thing here, go to L2, hit clear, and enter, and that gets rid of that whole list. So I'm going to put my X's on the left side, so 921, 933, 945, 968, 990, and 1002. And then on L2, I'm going to do my Y's, 129, 110, 102, 73, 45, oops, tapped something in wrong there, 45, and 37. So again, just make sure that you have the same number of entries on both sides, that they're the same, so that you can work this out well. So now that you've got your data typed in, we go back to stat, over to calculate. This data right here is linear data. I can tell because it's a line, and it said find the line of best fit, so I don't have to do a lot of thinking there. I'm going to go to 4, press enter a bunch of times so I get to the next screen, and notice I get way more information this time than I got last time. Okay, so I have all my data over here on the right, and I just took a picture of it because I didn't want to have to try and balance the video while I'm writing everything. So the first thing it asked me for is to use the table to find the equation for the line of best fit. So if I want to find the equation, then that means that I'm looking at this y equals ax plus b over here, and I need to write my equation using that. So that would be y equals, again, round to the nearest thousandth. Thousandth is 3 decimal places, so negative 1.146 to the x, or times x, plus b, which is 1182.246. So that would be my equation. And then I'm supposed to, part B, what is the correlation coefficient? R. So I'm just looking at this value right here, whatever R is, which R is, again, round to the nearest thousandth, negative 0.997. So what does that tell you about the type of correlation? Well, that gives you two things. First of all, the sign here tells you that it is negative correlation. So the sign tells us that it is negative correlation, which makes sense because if we look at this, our data is decreasing. And the second thing it asks is when it asks us for what type of correlation it has, so it's negative, and it's either strong, moderate, or weak. And you can go back and look at that number line. So 0.997 is between 0.7 and 1. So this is going to be negative, and the number itself tells us that it is strong correlation. So it's negative strong correlation. Then the next part C, what is the coefficient of determination? To find the coefficient of determination, we look at r squared, whatever r squared is. That's what gives us the coefficient of determination, which in this problem is 0.995. So, and again, don't do anything with that. I just want you to know how to find it because next year you're going to learn in statistics what to do with that information. So now, for parts D, E, and F, and then G, which you don't see G on mine, but you do see G on yours, so I'll write it in a second. D says we're going to just use the equation that we have from part A. So all of these right here, every single one of them, the next 4 requires information from part A. Using the model, what would be the wind speed of a hurricane with an air pressure of 956 kPa. So if they're giving us air pressure, let's go back and look at what information we have in our table. Well, air pressure here is my x's, wind speed is my y's, so they're telling me that x equals 956. So if I want to know what my wind speed would be, I just need to plug that in. I need to plug in 956 in for x in my original equation. So that's y equals negative 1.14. So I'm going to write that in green so you know where it came from. So y equals negative 1.146 times x, which would be 956, plus 1182.246. And that's something that you just put in the calculator. You literally just type all that in because you don't have to do any work to figure that out. And it gives you an answer of 86.67. So that'd be 86.67, and that's our wind speed, and wind speed is going to be measured in knots. So we want to make sure we include units here. And I know wind speed is measured in knots because it says right here wind speed is measured in knots. So part E, according to the model, a hurricane, let's finish then the rest of this question. Then it says, is this interpolation or extrapolation? So we looked at what the definition of this meant before. So interpolation means that what we're looking at is inside the data that we're given. And then extrapolation means that it's going to be outside the data that we're given. So all you have to look at to figure this out is you look at the numbers that you currently have. You look at what information you were given. And we look at this problem which says 956. So would 956 fall in between these numbers? If it would, it's interpolation. which it would in this case, because 956 is between 921 and 1002. So this problem would be an interpolation problem because 956 is inside the data that we're given. But let's look at problem E. According to the model, a hurricane with an air pressure of 865 kPa. Well, so if X in this case is 865, does 865 fall in this range of numbers? Is 865 between 921 and 1002? No. So that means that this would be extrapolation. But we're going to do the same thing. We just plug in 865 for X and we work it out and get an answer. So look at, and I'm not going to finish that one. I'm going to let you finish that one. Okay, look at F. The model indicates that a wind speed of 63 knots is associated with what air pressure? So this time they're giving us Y. So this time the information that we have is we know that wind speed, or Y, equals 63. So just kind of using some common sense, if I'm looking at this table, my answer should be somewhere between 73, should be somewhere between 968 and 990, because I'm looking at 63 falling in between these two numbers. So therefore, my air pressure should fall in between these two numbers. So I'm going to plug that into my equation still. So 63 equals negative 1.146x plus 1182.246, and I'm going to work backwards to find this out. So I'm going to solve this equation for x, which means I need to subtract 1182.246 from both sides. And that gives me negative 1119.246 equal to negative 1.146 times x. And then to get x by itself, I'm going to divide both sides by negative 1.146. And I get that x equals 976.65. And giving that units, that would be kPa, because that's what our wind speed was measured in. So that makes sense then with what we said, that our answer should be somewhere between 968 and 990. So that kind of lined up with that. So your last question, question G, and again, this one is on yours. I'm about to write it on mine. Says to interpret the slope in context. Okay, when you're interpreting the slope in context, there's basically a phrase that you're filling in, is really what it boils down to. That you're putting words to whatever number we ended up with for the slope. Our slope in our problem, by the way, was the negative 1.146, because that was the number that was attached to x in my equation here. The negative 1.146 was my slope. So we're going to use that number here to answer question G. So that says negative 1.146, and then the way our slope reads is it's going to be something per something, and we're just going to fill it in. And that's our y's, and it's always our y's per our x's. And basically we're just putting it in units. That's really what we're doing, is we're putting our slope into words, into units. So if you look at your y's, well, your y's were measured in knots, so it's going to be your knots per whatever your x's were measured in. Well, your x's were measured in, it didn't tell you this in the graph, I think it got cut off, but if you read through the problem, every time I talked about wind speed, it talked about kPa, which honestly I have no idea what that stands for. I'm sure you can Google it if you really want to know, but that's going to be, the rest of our part is going to be per kPa, so whatever that is. So our slope, what it's saying is that our slope is changing at a rate of negative 1.146 knots per kPa, so per whatever kPa is. That's our interpretation. So that should be enough to get you through. This assignment is going to be due on Wednesday. This assignment is due on Wednesday, and I will be back tomorrow, and I will gladly answer any questions that you have, and otherwise tomorrow you'll have time in class to work because you need calculators. So see you tomorrow.